chemistry. So today we're going to be still recapping the ideas of atomic structure. We're going to look at isotopes. Now for isotopes there is one aspect of this that is specifically for higher level papers, but we'll go through the whole thing. So looking at our progress questions as I've been trying to start the last couple of videos. First of all is how you describe and identify isotopes of an element. We're then going to look at the relative atomic masses for some elements and explain why they're not whole numbers. And for the higher candidates, how do you calculate the relative atomic mass of an element when we are looking at isotopes? So if we go back to looking at a model of an atom. Now we can see here we have lithium. Now looking at the periodic table and looking at the information we've got here, we know lithium has got 3 protons. If we look in each one of those pictures, we've got 3 protons. We know previously that atoms have no overall charge, so if we have 3 protons, we must have 3 electrons. And each one of those diagrams there shows 3 electrons. But there is one fundamental difference. If we look in each one, we'll look at the yellow particles, which are the neutrons. We can see in the first diagram, we have 1, 2, 3 neutrons. In the second diagram, we have 1, 2, 3, 4 neutrons. And in the third diagram, we have 5 neutrons. Now these elements are all still lithium because of those 3 protons. They will all behave in the same chemical way because of the 3 electrons around the outside of the nucleus, but they will have different masses. And that is what an isotope is. Often a 2 or a 3 mark exam question will ask you to state what an isotope is. And to make sure you get all the marks, you may need to ensure that you talk about all 3 particles. So an isotope is the same element with the same number of protons, the same number of electrons, and a different number of neutrons. And if an exam question shows you a diagram like this, you would actually show how many protons there were. So in this case, we would say an isotope is where lithium has 3 protons, 3 electrons. Some of the atoms will have 3 neutrons, some of the atoms will have 4 neutrons, and some of the atoms will have 5 neutrons. Now, moving on, we need to have a look at why the relative atomic mass of an element is not always a whole number. Now, if we look at an example here, which is chlorine. Chlorine has 2 isotopes. It has chlorine 35 and chlorine 37. Now, if half of all of the chlorine in the universe was chlorine 35, and then the other half was chlorine 37, to work out the average mass of chlorine would be somewhere between the 2, so it would be 36. But actually there are different amounts of different isotopes. So in the case of chlorine, there is a higher proportion of chlorine 35 than there is chlorine 37. And because the relative atomic mass of an element is a mean, is an average, it can be between whole numbers. So in the case of chlorine, it's 35.5. Now moving forward, for the higher level students, there is a calculation based on some data that we can use to actually work out the relative atomic mass of an element. If we have a look at a worked example for this. So here, we've got the abundances of the 2 isotopes of chlorine. So 75% of chlorine is chlorine 35. 25% of chlorine is chlorine 37. So to work out the relative atomic mass of chlorine as an average, as it's shown in the periodic table, we need to follow this simple formula. So we need to know the total mass of all of the atoms. And then we need to divide that by the total number of atoms. So we'll first of all deal with chlorine 35. So we know we've got 75% of chlorine 35. So we'll multiply 75 by 35. We then need, because we're working out the total mass of the atoms, need to add that to the numbers of chlorine 37. So we know we have 25% of chlorine 37 and the mass is 37. That will then give us the total mass of our atoms. We divide that by 100, which is the total number of atoms because we've been looking at percentages, and that will give us our value of 35.5. Now in the exam you are expected to remember that formula. You will not be given that formula. So you have to make sure that you learn how to use that, but also how to remember the formula. And that's all we're going to be having a look at with isotopes today. So it's a bit of recap. We have already done that. As previous lessons, I'll just bring up the extension question. So if any of you want to have a go at the extension question here, you can do the strengthen one as well, but the extension one is something we need to look at. Especially higher students, have a go at doing that. Send that in to me and I'll see how you get on. Thank you very much, and I'll see you next time.